Welcome to solverfy.
In this problem on the topic of oscillators, we are told that a seconds pendulum is a pendulum that can measure a period of exactly 2 seconds. So each one-way swing is exactly 1 second. We want to calculate the length of this pendulum in Austin, Texas, where we are given the acceleration due to gravity. We're then told the pendulum is moved to Paris, where the acceleration due to gravity is slightly different. And we want to know by how much we need to lengthen this pendulum. And lastly, we want to calculate the length of the seconds pendulum on the moon, where again we are given the acceleration due to gravity. We know in general that the period of a pendulum t is related to its length by the equation t is equal to 2 pi times the square root of L over g, where L is the length of the pendulum, which means the length of the pendulum L is equal to t squared times g over 4 pi squared. So if we first take this equation to Austin, the length of the pendulum in Austin, LA, is equal to t squared times the acceleration due to gravity at Austin, GA, over 4 pi squared. And so this is a period of exactly 2 seconds squared times the value for g at Austin, which is 9.793 meters per square second, divided by 4 pi squared. And this gives us the length that the pendulum will need to be as 0.992238 meters, or keeping our 4 significant figures, it's 0.9922 meters. Now, if we move this pendulum to Paris, we need to first calculate the length of this pendulum in Paris, LP, and LP is equal to t squared times the gravitational acceleration in Paris, GP, over 4 pi squared. And so if we substitute our values in, again, the period must remain at 2 seconds, and that's squared, times the gravitational acceleration, which is given to be 9.809 meters per square second, divided by 4 times pi squared. And so the length that the pendulum needs to be in Paris is 0.993859 meters, or again, keeping our 4 significant figures, 0.9939 meters. And so the length that the pendulum needs to be increased, delta L, is the length that's needed in Paris minus the length needed in Austin, which is 0.993859 minus 0.992238. This gives us the increased length in meters to be 0.001621 meters, or 1.6 millimeters. So we need to increase the length of the pendulum by 1.6 millimeters when going from Austin to Paris in order to keep the period at 2 seconds. Lastly, for the moon, the length of this pendulum, Lm, is equal to the period squared t squared times the gravitational acceleration of the moon, Gm, over 4 pi squared. And so again, this is a period of 2 seconds squared times the gravitational acceleration on the moon of 1.62 meters per square second, divided by 4 times pi squared. And so calculating, we get the length of this pendulum on the moon to be 0.164 meters.